Have you ever wondered how chemists discover the formula of compounds when they can't actually see the atoms they contain and count them? Well, in this simulation, we will show you how to deduce a formula of a compound by finding the ratio of elements present in it from the masses and the mole calculations. Copper oxide can be reduced by hydrogen and its formula determined. To determine the formula, we need to find the masses of the copper and the oxygen present in the oxide. Before we start the experiment, we took two measurements. Mass of the dish is 31 grams, and mass of the oxide of copper, which is copper oxide, and the dish together before the experiment is 35 grams. Which means that the mass of copper oxide is 35 minus 31 equals to 4 grams. We heated the black copper oxide and therefore it turned into copper. This is the reduction of the copper oxide. After the experiment, we measured the mass of the copper that is left in the dish, and that was equal to 34.2 grams. From this information alone, we can work out how much of the compound was copper, and that was 34.2, which is the mass of the copper left in the dish, minus the mass of the dish, which is 31, and that is equal to 3.2 grams of copper. The difference in mass between the copper oxide and the copper tells us how much oxygen was in the original compound, because copper oxide is made up of copper and oxygen. So the mass of oxygen is 4 minus 3.2, which is equal to 0.8 grams. What do you think we should calculate next? We have the mass, and given is the relative atomic mass of copper and oxygen. Well, now we can calculate the number of moles of each element present from the masses using their relative atomic masses. The relative atomic mass of Cu, copper, is 64, and that of oxygen, O, is 16. The number of moles is equal to the mass over the relative formula mass. So the number of moles of copper is equal to the mass of copper over the relative formula mass of copper. What's the mass of copper? 3.2, because we already calculated it, and given is the relative formula mass, which is 64. Dividing them together gives us 0.05 mole. The same thing goes for the number of moles of oxygen, where it is 0.8, the mass of oxygen, over 16, which is the relative formula mass of oxygen. This gives 0.05 moles. So as you see, the number of mole of copper is equal to the number of mole of oxygen in this case. So the ratio of copper to oxygen is 1:1. In other words, the formula is CuO. There is one copper atom and one oxygen atom in each copper oxide molecule. This is how we can find the formula of a compound by the calculation of the number of moles and finding the ratio of these calculations.